So this lesson is going to be on the photoelectron spectroscopy and how that relates to electron configuration. So what I have here is a PES, photoelectron spectroscopy, of some sort of an atom. Now what we notice here is we have different peaks, and down here we have the binding energy, which is also the ionization energy, all right? So we can look at in terms of the ionization energy. Now be careful, because on your test in May, they may give you ionization energy from large to small, or they may flop it and go small to large. So you need to pay attention to this bottom part here. This is going large to small. So the electrons, this peak represents electrons closest to the nucleus, and this peak is my electrons furthest from the nucleus, because I have less ionization energy. All right, the closer I am to the nucleus, the more attractive force I have between these electrons and the protons of the nucleus. As I move away, I have electron shielding, which shields these outer electrons from the full force of the protons within the nucleus. So this is my 1s, this is my 2s, and this is my 3s. All right, 1s, 2s, I'm sorry, not 3s. This is my 2p, excuse me. All right, this is my 2p. So how do these heights compare? And what does this tell us about the relative number of electrons? Because all of these heights are the same, we are going to notice that they have the same number of electrons. So the same height is the same number of electrons. So this is 1s2, 2s2, and this is going to be 2p2. So there's only 2 electrons here in the 2p. So if the peaks shown represent all of the electrons, identify this element. So 1s2, 2s2, 2p2 is carbon. Which peak represents the innermost electrons? It's going to be the first peak, because it has the highest binding energy. Okay. Those are going to be closest to the nucleus. So let's look at another example. Again, we are going from increase to decrease. So how many electrons are represented in each peak? So this is an increase. So here's my 1s. This is my 2s. This is my 2p. Notice my 1s and my 2s, they have the same height because they each have 2 electrons. Now we'll notice that my 2p here is twice the height as my 2s. So if 2s has 2 electrons and twice the height, 2 times 2 is 4. So my p has 4 electrons. So how many electrons does the atom contain? Total electrons, 4 plus 2 is 6 plus 2 is 8. How many electrons are in its valence shell? 4 plus 2 is 6 valence electrons. So what is our electron configuration? It is 1s2, 2s2, 2p4.